Welcome class. Today we are going to continue with exercise 12.2. So today let us begin with question number 7, and there are 4 questions as homework from question number 9 to question number 11, and the last question, that is question number 14, is your homework, and the rest questions I have explained in this video. So let us begin with the exercise. Question number 7 states, a chord of a circle of radius 12 cm subtends an angle of 120 degree at the center. Find the area of the corresponding segment of the circle. Use pi as 3.14 and root 3 as 1.73. First of all, let us write what is given in the question. We are given radius as 12 centimeter and theta, or the central angle, is given as 120 degree. Now if you must see the diagram, children, this is the chord AB and this is the sector that is formed AOBP. Okay, in the question it is saying a chord of a circle of radius 12 centimeter. So if the radius is 12 centimeter, that means OA is 12 centimeter and OB is also 12 centimeter. Right, we have to find the area of the corresponding segment of the circle. So over here, the corresponding segment, that is the minor segment they are talking about. Particularly this segment they are talking about. Okay, so for that, first of all, what we are going to do, we are going to find out the area of the sector minus the area of the triangle. We will get the answer of the area of the required segment. Alright, now let us take out the area of the sector. Please copy this diagram. Yes, area of the sector, we know the formula. It is theta upon 360 into pi r square, which is equals to theta is 120 degree upon 360 into pi is to be taken as 3.14 into r is 12 into 12. So zeros will be cancelled. 12 ones are 12 threes are, 3 ones are 3 fours are 12. We are left with 3.14 into 4 into 12, which will give you the answer 150.72 centimeter square. This much is clear. Now the most important part comes is to take out the area of the triangle AOB. Alright, first understand with the help of the diagram that is given here. In this triangle, we are going to drop a perpendicular from O to B. Alright, let this point be D. Now, if you see that this is 12 centimeter, this is 12 centimeter, the angle over here is given as 120 degree, isn't it? This is given as 120 degree. When we are dropping a perpendicular, it is getting divided. So over here, instead of 120 degree, we can write this as separately 60 degree and 60 degree. Since it is getting divided into 60 degree each and a perpendicular is dropped, it will become 90 degree and 90 degree. Right? Why are we needed this? Why have we drawn the perpendicular? We are and which will be helpful for us to bisect the angle as well. Because for the triangle, if you must know the formula, it is half into base into height. So for the height, we know this. We want this perpendicular. All right. Now let us write down the statement. Here, we are going to write down, consider triangle AOB from point O, drop a perpendicular onto AB. So if you will see again in the diagram, we know this is 60 degree, this is 90 degree. We do not know angle A. So with the help of angle sum property of a triangle, we will be able to find angle A. Alright, so here we are going to write angle OAB is equals to 180 degree minus 90 degree plus 60 degree. This will give us the answer as 30 degree. You will get the answer as 30 degree. Now, over here, the angle that we have found is of 30 degree, right? 60, 90 and 30. So now we are going to take over here cos 30 degree. We are going to take over here cos 30 degree. We will write cos 30 degree is equals to AD upon OA. AD upon OA. If you must see in the diagram here, this is AD and this is OA. That means base upon perpendicular we are taking. Cos 30 is how much? Base upon perpendicular, right? Why is it needed? Because we do not know as of the length of any of these things. Now, excuse me, AD upon OA, sorry. Yes, this is AD and this is OA, not this one particular OD and OA. So over here, we will write cos 30 degree, we know the value, it is root 3 by 2, isn't it? Cos 30 degree, we know it is root 3 by 2. Here we have AD and OA, we know since OA is the radius, so this will be 12. From here we will be able to find out the value of AD, which implies AD is equals to 12 root 3 upon 2. This gives the answer 6 root 3 centimeter. Now we have the measurements. We can move further with this point. We will write here. We know OD bisects AB, isn't it? So AB can be written as twice of AD, and twice of AD is how much? Twice of root 6 root 3. So this will give us 12 root 3, right? Now we will take over here sine 30 degree. Sine 30 degree, we are going to write it as OD upon OA. Why OD upon OA? What is the ratio, trigonometric ratio of sine 30 degree or sine theta? If you must see over here, it is written OD and OA. That means perpendicular upon hypotenuse. So here we will, with the help of this, we will be able to find the length of the hypotenuse, which implies sine 30 degree is written as 1 by 2 and OD upon OA is OD upon 12. So this will be 2 ones are 2 six are. OD we get it as 6 centimeter. Alright. So what values we required? We required AD 6 root 3 centimeter and we required OD. If you see in the diagram, we required OD and AD, isn't it? So now that we have found out OD and AD, we will be able to find the area of the triangle, right? So from here, this will be area of triangle AOB is equals to half into base into height, which is equals to half into base into height, that is 12 root 3 multiplied by 6. This we get it as 36 root 3 centimeter. On conversion of 36 root 3 in the question, it is given as 1.73. So we will write 36 multiplied by 1.73. We get the answer as 62.28 centimeter square. Now that we have the area of the sector as well as area of the triangle, we will subtract both these. So therefore, area of the corresponding segment, is equals to area of the sector minus area of triangle AOB, which is equals to 150.72 minus 62.28 centimeter, which will give you the answer as 88.44 centimeter square. This completes question number 7. Now let us move on to question number 8. Question number 8 states, a horse is tied to a peg at one corner of a square-shaped grass field of side 15 meter by means of a 5 meter long rope. First, we have to find the area of that part of the field which the horse can graze, and second, the increase in grazing area if the rope were 10 meter long instead of 5 meter long. Excuse me. So here, first of all, let us see the diagram. This is the particular square field, right? And this is from where the horse is tied, right? And this is a 5 meter long, and therefore it forms a when the horse is grazing, suppose this is the horse, and when it is grazing, it will move up till this point, say X and Y. So this much of area it is covering, right? Now let us begin. First, let us write what is given in the question. We will write, also it is given that the side of the square is 15 meter. Alright, so we will write length of the side of the square field is 15 meters by a long rope that is of 5 meters. So length of the rope is 5 meters. Alright, let us start with the first one. In the first part, we have to find the area of that part of the field in which the horse can graze. Now if you see, children, this is a square. Alright, if we were to determine theta, we all know that the angles of the square are always 90 degree. So from here we get theta as 90 degree, isn't it? So for the first one, you will write as all the angles of a square is 90 degree. Therefore, the central angle or theta will be equal to 90 degree, right? Now, the length of the rope is given as 5 meter, which will act as the radius. So, radius is equals to 5 meter, length of the rope. Right? Now, if you must see, children, this particular diagram, this is forming a sector, isn't it? This is forming a particular type of sector. So we will write here area of the field that horse can graze is equals to pi r square multiplied by theta upon 360. Pi r square, we have to use 3.14. into r square is 5 into 5 into 90 upon 360. So this will become 1 by 4. We are left with 3.14 into 25 divided by 4. So 3.14 multiplied by 5 into 5 upon 4. You will get the answer as 19.625 centimeter square. Copy down this much, children. Now let us move on to the second part. They are saying if the rope is increased to 10 meter. Alright, so here the radius is changing. We will write here when the length of the rope is 10 meters. So over here we are going to write radius is now 10 meters. So the area will be how much? Theta upon 360 into pi r square. That is 90 upon 360 into 3.14 into 10 into 10. This will be 1 by 4. So 3.14 multiplied by 10 into 10 will give us 314 upon 4. The answer will be 78.5 meter square. After finding this out, if you see the second part of this question, it's written the increase in the grazing area. This is the area where the radius has increased to 10 meters. Okay, now how much it has increased, that we have to find out. So we will write area increased is equals to 78.5 minus 19.625. The answer is 58.875 meter square. This completes your question number 8. Question 9, 10 and 11 are your homework, children. We will begin with question number 12. Question number 12 states that to warn ships of underwater rocks, a lighthouse spreads a red colored light over a sector of angle 80 degree to a distance of 16.5 kilometer. Find the area of the sea over which the ships are warned. That means underwater there are so many rocks that a lighthouse has to spread a red colored light so that the ships come to know. So if this is a particular lighthouse, then the area that it covers, okay, it forms a particular type of sector. Like for example, if this is the water, then at this particular area the light spreads. The angle over here is given as 80 degree and to a distance of 16.5 kilometer. That means this particular lines that they go, known as 16, is they are at a distance till 16.5 kilometer. So if you see this particular sector, children, here this is central angle theta. The distance that it is spreading the light 16.5 will become the radius. Therefore, we have to find the area of the sea over which the ships are warned, that will be equal to the area of the sector, right? So first of all, we will write what is given. Angle of the sector. Angle of the sector is equals to 80 degree. Distance covered. Distance covered is equals to 16.5 kilometer. Therefore, the radius is how much? Radius will be 16.5 kilometer. So area of the sector formed is equals to theta upon 360 into pi r square, right? So let us write down theta is given as 80 upon 360 into pi, we have to use it as 3.14 into 16.5 into 16.5. 0, 0 gets cancelled. This is 2 4s are 2 18s are, 2 2s are 2 9s are. We are left with 2 multiplied by 3.14 into 16.5 square divided by 9. Your answer will be 189.97 kilometer square. This completes your question number 12. Please pause it and copy the question. Now let us move on to question number 13. Question number 13 states, a round table cover has 6 equal designs as shown in the figure 12.14. If the radius of the cover is 28 cm, find the cost of making the designs at the rate of rupees 0.35 per centimeter square. Okay, so first of all, we are going to write what is given to us. Radius of the cover is given. Radius of the cover, that is 28 centimeter. The central angle we have to find out for this, and they are asking the cost of making the designs at the rate of 0.35 per centimeter square. So if there are 6 equal designs, what will be the angle at the center? Okay, so angle at the center will be how much? 360 degrees. Now since it is forming a square, you can a hexagon figure, if you may see. Okay, and this is the circle that it is encompassing. Just a second. All right. Okay, if you will see this particular diagram, see here, assume that it is joined, huh? So here, if the radius, if this is the center point and the radius is given as 28 centimeter, right? The radius is given as 28 centimeter. So each angle will be, this is whole is 360. How many parts it is getting divided into? It is getting divided into 6 parts. Therefore, the angle at the center will be how much? For every part, it will be how much? 360 degree divided by 6, which will give us 60 degree. Now, we will find out, now since they are all equal, okay, since they are all equal, we are going to find out, in the question they are asking, to find out the area of the cost of making the designs at the rate of 0.35 centimeter square. So for that, we are going to take one sector, subtract this particular triangle, and we will be left with only the designs. That means we have to find out the area of the sixth segment, right? So let us start with this. After finding out the theta, we will write over here area of the sector formed is equals to theta by 360 into pi r square, right? Here we have to use pi as 3.14 again. So we will write here 60 upon 360 into 3.14 into 28 into 28. This will be 1 by 6. We will get the answer here 410.66 centimeter square. Now over here we need the area of the triangle that is formed. Okay. So let us find out the area of the triangle that is formed here. We all know that the two arms of the triangle are the radii of the circle and thus are equal, isn't it? If you must see the diagram here, The radii are equal and central angle is given as 60 degree. Okay, the central angle is given as 60 degree. Now we all know that if one angle is given as 60 degree and the two sides are equal, naturally the third side will also be the same and these angles will also be 60 degree each. Therefore, if all the angles are 60 degree each, it will be an equilateral triangle, right? So we will write over here, since the radii are equal and the central angle is 60 degree, therefore triangle AOB is an equilateral triangle. Equilateral triangle. Let us name one of the sides, for example this A, B and the center point as O. So AOB as an equilateral triangle. We are going to find out only one particular area, children, and then we are going to multiply it by 6 because in the question only it is given that they are equal. Now, area of equilateral triangle is how much? You must have studied in the previous classes. Area of equilateral triangle is equals to root 3 by 4 into a square or side square units, right? So over here we will write down, the side is obviously OA, so we will write down root 3 by 4 into 28 square. So 4 ones are 4 sevens are 28 into 7 into root 3. We will get the answer as 333.2 centimeter square. Now we know the area of the sector, we know the area of the triangle. We are going to subtract the two and we are going to left with the area of the segment, that is the area of the design, right? So we will write down therefore area of a single design. First let us find out for 1, then we are going to multiply by 6. Area of a single design, in bracket write down segment, is equal to area of sector minus area of triangle AOB, which is equals to 410.66 centimeters square minus 333.2 centimeters square. We are left with 77.46 centimeter square. This much is clear, children. See, sector we already found out the area. Here we also found out the area of the triangle as well as the area of the single design. Alright. Now if one design is 77.46 centimeters square, therefore area of 6 designs will be how much? It will be 6 into 77.46. You will get the answer as 464.76 centimeter square. Therefore, the total cost, we know one cost is per centimeter cost is given as rupees 0.35. So total cost will be how much? It will be 464.76 into rupees 0.35. We will get the answer as rupees 162.66. This completes your question number 13. Alright. And question number 14 is your homework, children. So you have 4 questions as homework from 9 to 11, 9, 10, 11 and question number 14. With this we complete exercise 12.2. In the next live class we are going to discuss the last topic, that is areas of combination of plane figures, followed by the exercise. Thank you so much, children. God bless you.